Welcome to the Deep Dive, the Generation Digital podcast on AI and how it's actually used at work. Generation Digital are AI consultants helping organizations move from ideas to execution. You can find out more and speak to us at gend.co.
Okay, let's try to unpack this. Think for a moment about how you interact with a computer right now. You're probably tapping a screen, maybe you're shouting a command, or you're, furiously typing on a keyboard.
All of those actions, however fast they might feel, they have latency, they're translations.
Yeah, they're bottlenecks, essentially.
They are. And if you think about the speed and the complexity of the AI systems we're building now, those physical inputs are by far the slowest part of the whole process.
Right.
We're constantly trying to translate this complex, immediate intent through, these really constrained physical or verbal pathways before the machine even gets to the message.
And that friction, that fundamental gap between thought and, execution. That's exactly what makes this recent strategic move by OpenAI so significant.
It's a huge deal.
We're diving deep into their investment in a neurotech startup called Merge Labs. And the mission here, it's not just iteration. It's to fundamentally leapfrog those old input methods.
It's about creating a direct bridge between biological intelligence and artificial intelligence.
Exactly. So the whole point of this deep dive for you listening is to really get what they're trying to do, to understand the strategic and the technological direction they're going, specifically with this non-invasive approach.
And to ask the big question, right? What happens to human ability, to our agency, when your mere intent can be expressed directly to an AI, when you move beyond the physical lag of today's devices?
This is where the conversation moves really quickly from, say, science fiction to actual business strategy. OpenAI is positioning these brain-computer interfaces, or BCIs, as the successor to our current I/O methods. But before we get into the tech, I think we need to establish the competitive context.
We have to. Let's start with the specifics. The main action here, what the sources detail, is that OpenAI participated in Merge Labs' seed round.
So this isn't just a grant or something.
No, not at all. This isn't philanthropic. This investment is meant to accelerate BCI research and development. It's putting serious corporate weight and capital behind a technology that could redefine the entire human-AI relationship.
And their core hypothesis, it just perfectly explains why a major AI firm, a company that makes its money on software and models, is suddenly looking so much closer at hardware and, human biology.
They believe that progress in interfaces unlocks progress in computing. That's the key phrase. They see BCIs as the next frontier for how we interact.
So it's less about building better models in a vacuum.
Exactly. It's more about enabling a faster conduit to those models.
That framing is really crucial. In Merge Labs, what's their stated mission in all this?
Their mission is to bridge biological and artificial intelligence and to maximize human ability. And they see that happening by combining three really hard-to-master things.
Sure.
Biology, advanced sensing devices, and, of course, AI.
So it sounds like a declaration almost, that real transformative AI progress is basically being held back by how inefficiently we can speak to it.
That's one way to put it. And if we look beyond just the stated mission, what's really fascinating here is the strategic intent.
What a huge AI firm moving this close to hardware and biosensing really signals.
Precisely. It signals a desire to help shape standards and models for neural data.
From the ground floor.
From the very beginning. I mean, if you're the one helping define the inputs, the format, the frequency, the fidelity of the human neural signal, you are in an incredibly powerful position to train the next generation of AI models that will interpret all this sensitive data.
So this isn't just about finding the next cool gadget.
Not at all.
It's about controlling the infrastructure that feeds all future OpenAI models.
Okay.
It's about data dominance in a field that barely even exists yet.
It's about building a data moat. That's what it is. Whoever sets the standard for collecting and processing reliable neural data first will have a massive competitive edge for decades to come.
So they'd effectively control the next API of the mind.
That's the prize. This investment is as much about influencing policy and the beta landscape as it is about just developing a piece of hardware.
That context on setting standards is so important, especially when you look at the specific tech Merge Labs is going after. Because they're not following the route most of us think of with BCI headlines, the ones that usually involve surgical implants.
And this brings us to the critical distinction of this whole collaboration. the laser focus on non-invasive or minimally invasive modalities.
Oh,
They are explicitly moving away from surgical electrodes or implants. Those are, high fidelity, but they also carry significant risk and are mostly limited to medical uses.
but the second you say non-invasive, the next question is always signal quality, right?
Always.
Historically, things like EEG, those head-worn sensors.
Yeah.
They're accessible, sure, but the signal is often noisy, it's shallow, or it's just too slow to capture complex intent in real time.
And the sources give us a really critical technical nugget here. Early signals are pointing specifically toward ultrasound-based tech or other deep-reaching non-implant modalities.
Ultrasound. What ultrasound?
It's all about spatial resolution. Traditional non-invasive sensors, they really struggle to tell the difference between activity from deep brain structures. You just get this sort of general blur of activity on the surface.
So ultrasound is being looked at as a way to see deeper into the brain, to target specific neural circuits, all without needing to physically go through the skull.
That's the hypothesis they're trying to accelerate research on, and that's how they plan to overcome that key signal quality challenge that has plagued accessible BCIs for decades.
And that focus on accessibility, on non-invasive tech, it seems to align perfectly with what they're saying about human-centered design.
It does. They need to create form factors that people will actually, wear and use in daily life. This is about moving the technology out of the hospital and into the consumer and workplace realm, even if the first step is just research.
I think we should clarify the division of labor here in this partnership, because it's important for you to understand the distinct roles. What is Merge Labs bringing, and what's OpenAI contributing, besides the capital?
Okay, so OpenAI contributes their core competency, their expertise in AI models. They know how to scale, deploy, and refine these huge foundation models. They have the architecture required to make sense of just vast amounts of data.
Merge Labs is all on the hardware and the data side.
Yeah.
The sensing and modulation of brain activity.
You build the device that reads the signal.
Yeah.
Exactly. But the essential bridge between the two, that's the data pipeline and the specialized AI you need to handle it.
Yeah.
So Merge Labs is responsible for pairing that raw neural data with foundation models that are specifically tuned for neural signals.
Okay, that's a crucial distinction we should probably underline. When we talk about AI models today, most people immediately think of large language models, LLMs, like GPT.
Right.
But a neural signal model is functionally different, isn't it?
Fundamentally different. A large language model is built to interpret grammar, syntax, context, meaning within symbolic language, the words we use.
Right.
A neural signal foundation model, on the other hand, is designed to interpret things like temporal spike patterns, frequency changes, blood flow data. It's the non-symbolic expression of intent itself.
So you're moving from decoding what you type
To decoding what you mean, instantly.
Wow. So this collaboration, it's simultaneously trying to solve the hardest problem in neurotech, getting robust, reliable, deep neural data without surgery, and then applying the most sophisticated AI models available to decode that signal.
The ambition is truly immense. It really underscores that this investment is about enabling a whole new class of computing, not just improving an old one.
Let's move from those huge technical challenges to the practical promise, because this is where your agency as a listener really comes into play. Why should the average person care if some ultrasound device can eventually read their intent?
Well, the immediate near-term payoff is just...
Better input-output.
Yeah. Think about just eliminating the friction we have now. The goal is to create interfaces that can accurately read intent and provide feedback, making AI more useful, accessible, and controllable for everyone.
So we're moving past the age where you have to yell, Alexa, stop, 3 times at your smart speaker just to turn off the lights.
Right. The promise is silence, seamlessness, and immediate compliance, because the machine can anticipate your need from a pre-conscious neural signal.
And if we look longer term, the high-impact applications are, they're truly transformative.
Yeah.
Especially in assistive tech.
Which is the historical core of all BCI research. Long-term, these interfaces could dramatically improve communication for people with motor or speech impairments.
Giving them entirely new, non-muscular ways for expression and control.
Exactly. And the technology holds immense promise for neurorehabilitation, too, by using these continuous closed-loop feedback systems that the sources mentioned.
And then for the general population.
Yeah.
The applications move into enhancing things like learning and refining human-AI collaboration, I assume.
That's right. Imagine if an AI understands your intent, before you even finish formulating the physical command, say in a CAD program or a complex modeling task.
The human-machine partnership would accelerate dramatically.
And that's what we mean by enhancing your agency. It's the promise of being able to express intent more directly to these incredibly sophisticated AI systems. You move from being an operator, limited by how fast your fingers can move, to being a genuine collaborator, potentially speeding up that thought-to-action cycle in a huge way. But the moment we start talking about directly reading intent from the brain, we have to acknowledge the massive challenge here goes way beyond technology. It's deep into governance and ethics. We can't just gloss over that.
Absolutely not. The moment you cross that barrier into reading neural data, you are dealing with the highest possible level of data sensitivity.
Right.
Brain data is profoundly more intimate than biometric or even genetic data because it holds the raw material of thought. The stakes for privacy and agency are just immense, which is why Merge Labs has listed these core design constraints right alongside their technical goals. They know that without addressing this head-on, consumer adoption is impossible.
It's a non-starter.
So what are those foundational constraints they're committing to?
They cite privacy, consent, and safety as core non-negotiable design constraints. This has to be baked into the development from the very earliest research phase.
And this leads to a fascinating policy problem. We have frameworks for, PII, personally identifiable information, and PHI, protected health information.
Right.
But where does raw neural intent data fit? It's arguably more sensitive than either of those, yet our existing policies have no real mechanism to govern it.
That's the gap. And OpenAI's involvement, they're signaling that they want to shape the standards. It shows they know they need to develop rigorous privacy, safety, and ethics frameworks proactively. They have to get ahead of the regulators.
They're trying to influence the competitive standard to build the trust they need for this to ever scale.
They have to, which puts pressure on policymakers. It raises a really important question. If an AI system is interpreting your intent, your desire to search for something or buy something, before you even consciously formalize that thought.
What does consent even mean in that scenario?
Right. Can you consent to the processing of a preconscious thought? That is the philosophical and legal hurdle they have to clear. The industry knows that without public trust, this technology just cannot and should not scale beyond a lab.
The race to decode the brain has to be matched by a race to regulate its data responsibly.
100%.
So for you, our listener who wants to track this, what are the specific actionable milestones or progress indicators you should be watching for to gauge the trajectory of this research?
I'd say there are 3 critical areas to monitor based on the sources. First, watch for papers or prototypes on signal quality and decoding accuracy.
Okay, that makes sense.
A non-invasive approach is only viable if the signal is clean enough to interpret complex intent. If the decoding accuracy stalls, the whole project stalls.
Good signal quality is the foundation for everything else. What's the next milestone?
Second, look for progress on closed-loop control and safety prototypes. Closed-loop control means the device can read the signal, have the AI perform an action, and then provide feedback back to you, the user.
Creating a continuous, stable interaction.
Exactly. And safety validation here is just paramount, especially with how experimental this sensing tech is.
And the third area, I'm guessing, moves back into that policy sphere.
It does. The third thing to track is any progress on policy and standards. Look for industry guidance on neural data handling, evolving consent protocols, and just see how the regulatory pathways, both for medical devices and consumer tech, start to evolve to handle this entirely new category of information.
Policy changes will dictate the speed and scope of deployment.
For sure.
This has been a really insightful look at the future of input. It's so easy to get tunnel vision on just the foundation models, but this investment, it signals a major strategic pivot. They're viewing the human brain as the next primary input device for AI.
Moving interaction past the limitations of the physical world.
Yeah.
This move basically confirms that the technological race is shifting. It's not just about who has the best LLM anymore. It's about who can create the most seamless, high bandwidth, and regulated connection to that model.
That's where the next leap in computing power will come from.
I believe so.
So what does this all mean for you as you track this future? If this research progresses, and given that this non-invasive tech is research first, it's not immediately a regulated medical device, you should really consider the implications of that regulatory time lag. What kind of non-implant devices, beyond strictly medical applications, will we see enter the consumer market first? And how rapidly will our existing regulatory pathways have to adjust to the flood of sensitive neural data that's going to follow?
That gap between rapid consumer tech deployment and slow policy formation, that's where the most significant societal challenges always emerge. So keep exploring that intersection of neurotech, foundation models, and governance. That's ground zero for the future of human-AI collaboration.
Thanks for listening to The Deep Dive. For practical AI consultancy and advice, visit gend.co.